So how do I display categorical data? So this distribution of categorical variables lists the categories and gives either the count as the percent or number of individuals who fall in that category. Individuals, participants, objects, right? They don't always have to be people. Pie charts show the distribution of a categorical variable as a pie, where the size of the slices reflect the count or percents for the categories. Another example, another way to express categorical data could be a bar graph, right? Bar graphs represent each category as a bar, and it's really important that those bars don't touch, but the height shows the category count or percentage. So let's look at a couple examples. So let's look at a pie chart. So for example, what do 1.5 million full-time first-year students plan to study? So what's their declared majors? So here are data on the percents of post-secondary first-year students, post-secondary meaning college, if you didn't know that already, who plan to major in several discipline areas. So here is a table. And if I was to ask you what value occurs, what group has the smallest percentage, you'd have to kind of like scroll through this data, right, to see, oh yeah, it's physical sciences. And then what value has the greatest? Well, again, you'd have to scroll through and then verify, oh yeah, it's biological sciences. But pie charts can help us visualize that. So here's our visualization. We can see the smallest pie slice goes to my physical sciences, while the largest goes to our biological sciences. Now this is great, but it's sometimes hard to see which is the biggest, right? Is biological sciences really that much bigger than others? Yeah, it is, but it's hard to visualize that. Is social sciences that much different than engineering? Well, if I look at this table, oh yeah, I can see that there's a difference, but it's hard to tell from this visual. And that's when a pie chart could be more beneficial. So let's take this same data set and express it as a pie chart. Note there was a rounding error, and that's okay. We still just pretended like it was a whole 100%. So here's our bar graph. As we can see, when you look at the bar graph right away, I know, okay, biological sciences are the biggest and physical sciences are the smallest. It even makes it easier to compare engineering and social sciences, right? You can see social sciences is actually a little bit shorter. So when it comes to a bar graph, it's kind of easier to quickly visualize which is the largest and which is the smallest. One unique thing we can do with bar graphs, and only with bar graphs, is we can arrange them from smallest to largest, and we actually can call those a Pareto chart. So let's take a look. So what sources do Americans aged 12 to 34 years use to keep up to date and learn about music? No promises that this data is accurate. By accurate, I mean current. Okay, so here we have our table, and I can see, okay, yeah, the least amount of people use Google Play. The most amount of people use Spotify. That tracks, right? But if I arrange them from smallest to largest, because they're a category, there's no numerical order, I can see right away, oh yeah, Spotify is the greatest and Google Play All Access is the smallest. Whereas before, if I just had a table, I'd have to like search the whole thing. And for bar graphs, they don't necessarily add up to 100%. We are going to have some rounding errors. We could have excluded values, right? I don't know. Some people might still use an iPod or a Zune. Probably not, but still.